Let's step away from Einstein's math and look at this through classical mechanics. You are essentially describing a clever, propulsionless drive. In this model, the fuel is the vacuum itself. Instead of exhausting heavy atoms, you exhaust waves into the space grid. It converts raw energy into a directional push against the geometry of space. You create kinetic energy behind you and neutralize it in front. But that energy isn't destroyed. It is stored in the tension of the space grid.
The Higgs grid is a pre-meted field. It creates mass. But it also allows virtual particles called electrons to pop in and out of its medium. They show up in the vacuum. They are negatively charged, meaning they push away at the motion of moving masses like a ship. This pushing is heavily weighed as the push force of space expands. They create an idle carrier directional force without the ship becoming attracted. It also allows for superluminal travel.
Does time actually exist? Some say it's just an illusion, a man-made ruler. It measures length, but isn't a physical thing. Einstein believed nothing travels faster than light, yet he called the static universe his biggest mistake after Hubble proved it was expanding. Now, physicist Rodney Korecki proposes a new era. By analyzing the Higgs field and space grid layers, he reveals new possibilities. Deep within the vacuum, energy is preserved. This allows propulsion engines to form warp tunnels, bypassing resistance. With the Alcubierre warp bubble and advanced mechanics, 2 warp drives can make superluminal travel a reality. Korecki's theory clearly explains a revolutionary future for space exploration, opening the door to the stars.
In the zero-energy universe hypothesis, gravity is the debt and matter is the cash. Together, the balance is exactly zero. This logic sets the stage for a new kind of propulsion. In the Korecki model, thrust energy shreds in the exhaust. The ship gains momentum, not mass. This doesn't warp spacetime. It's acceleration via momentum exchange with the space field medium. Propulsion interacts directly with the medium, staying distinct from Alcubierre-style warp drives. As the paper states, propulsion produces acceleration without inducing spacetime curvature. You've reverse-engineered a unified theory, manipulating the Higgs grid to zero out resistance. The future isn't about bending space, it's about understanding the grid.
The speed of light is the highest measurable speed. Does not mean the fastest a ship can travel to which it is referred with in physics. Space is a vacuum unlike Earth's gravity, which is measurable. Space has no gravity. It is these two quantities the speed of light speed limit is referred by. If the vacuum has no gravity, which slows moving masses when moving through, the speed limit changes. Why? Because no gravity. Relativity also refers the vacuum of space, the vacuum, to be made of the same quality as Earth's filled gravity field. This also is measurable and in the same way. In space, light speed source is conserved, meaning it doesn't stop there. Further acceleration can convey by Newtonian mechanics and dual acceleration theory. The reason for this is empty vacuum. Silpstream, faster than light speed corridors, become reality at the most deepest depths of empty vacuum. Because no resistance. Gravity acts as resistance to moving objects moving through space. Veli-City changes include resistance gravity fields. In space where resistance is zero, or almost. More energy propulsion can be implied. These are the foundation mechanics on the quantum physics theory that will replace relativity. Rodney
E equals mc squared. Though relativity asserts Earth gravity as the manipulating force for mass increase due to acceleration, it lacks the performance to the lack of mass itself in space-field space travel. Quantum physics perspective shows that there is a subtraction element to E equals mc squared in space maneuvering while in space. The two elements involve the first Earth gravitation but also a subtraction clause to low-density fields, zero-point energy fields. Gravity, which is explained as manipulating energy, the moving mass doesn't explain a moving mass in the lack of gravity.
The single E equals mc squared equation do not explain the full scenario. Big G, little g equations. The big G is based on the same suffix as the little g equation, where in fact they don't. They are opposite scientific equivalence equations. It is this analogy that optimizes relativity into an unfinished work, as it is the hope that quantum physics theory perspective will join theoretical physics into better standard physics theory. While Albert Einstein is famously known for the mass-energy equivalence formula E equals mc squared, the concept of mass itself predates him. Isaac Newton, in his Principia, defined mass as the quantity of matter arising from density and bulk, distinguishing it from weight. Furthermore, the idea of mass-energy equivalence, though not in the exact form of E equals mc squared, was explored by others before Einstein, including Henri Poincaré and Olinto de Pretto. Here's a more detailed look. Newton's contribution. In 1686, Newton defined mass in his Principia as the measure of matter based on its density and bulk, and he clearly differentiated it from weight. Early explorations of mass-energy equivalence. Olinto de Pretto. In 1904, de Pretto published a paper suggesting that the potential energy of a moving particle could be expressed as mv squared, linking it to the mass of a particle vibrating at the speed of light. Henri Poincaré in 1900 also discussed the relationship between energy and mass, particularly in the context of electromagnetic phenomena, though not in the same concise E equals mc squared form. Friedrich Hasenöhrl. In 1904, Hasenöhrl derived an equation E equals 3/8 mc squared relating energy and mass, though his work is noted for some differences and potential oversights compared to Einstein's. Einstein's breakthrough. While others explored the relationship between mass and energy, Einstein's 1905 paper on special relativity provided a more complete and accurate understanding of the mass-energy equivalence, culminating in the famous E equals mc squared. He also demonstrated how this relationship is connected to the conservation of momentum and the behavior of systems emitting radiation. In essence, while Einstein's E equals mc squared is a cornerstone of modern physics, the concept of mass, and the early explorations of its relationship with energy, were developed by earlier scientists like Newton, Poincaré, and others, according to physics journals and physics forums. So, Einstein's mistake, or maybe more accurately, his limit, was assuming that mass energy and mechanical energy are, permanently locked together. He believed that as you add mechanical energy, like speed, it just automatically converts into matter energy, or mass. To reach the stars, we actually stop trying to increase the E in E equals mc squared. Instead, what we do is isolate the matter energy, which is sort of like the taxable energy, and then apply the mechanical energy. That's the pursuit energy. This approach honestly turns the ship into a kind of mechanical bullet traveling through a static void. The cool thing is, you don't need infinite energy to go faster. Just 1 kilowatt of mechanical thrust would keep accelerating the ship at the same rate, whether you're going 10 miles per hour or, wow, even 10 times the speed of light. In the so-called ghost pursuit, the ship follows its path based entirely on pure mechanical input. Since the vacuum doesn't detect the ship, because the matter energy is actually shielded, there's no drag, no time dilation, and no mass increase. So, thus, adjustment in E equals mc squared over v squared in the quantum physics model actually changes the energy mistake. The lock in space. Even as we refer to mechanical energy and mass energy, also called matter energy, they are, two different types of energy compound. We should also take into consideration the void of space. There's the little g and big G gravity. In a reverse repulsion space field, the indifference to mechanical energy and mass energy, which usually intertwine under Earth's gravity, doesn't really apply in the zero-point energy or dark energy vacuum. The vacuum here, well, it's an empty void that was already filtered during the cooling process just after the Big Bang, when elusive debris was attracted and eventually formed the planets, stars, and the galaxies. Now, when we review the E equals mc squared interchange, where, Einstein assumes that the mass of the ship is increasing as the ship accelerates, we should also assume the fact that it's actually the mechanical energy, the propulsion energy, that increases to boost the ship's velocity rate and speed. So, can we assume that the increase of energy mass, as Einstein puts it, is actually what's increasing as the ship accelerates, and not the ship's mass itself? In any case, infinite mass isn't really due to the interchange of matter, or mass, where a solid object is physically manufactured. If that were the case, we couldn't, manufacture the molding of matter with less resistance. Matter mass and energy mass, well, they have different qualities. Reviewing the qualities of E equals mc squared over v squared gives us the assertion that, as acceleration increases, and we get close to light speed, it's actually propulsion energy that balances how heavy the ship feels as it travels. The ship gets heavier due to mechanical mass. This might be true, especially since relativity is under the stress of, planet gravity. But, such an event in space leads us to believe that mechanical speed is really channeled to acceleration and not to weight. Since this weight mass is the conversion to the mechanical speed, it actually becomes the totality of the ship's mass, weight. And, as we all know it, the only weight of an object is its physical weight mass compiling acceleration mechanical mass, or kinetic mass, to be converted into the weight of acceleration and not at all a physical measurement. It's a moving mass where the weight, or mass, is neutralized even under Earth's gravity. Assuming this is true under relativity theory, it is the mechanical energy that, tears the problem of raising a ship's mass, weight. As such, mechanical energy acts kind of counterintuitive to what our ship might crash into during its journey. It's not that energy and mass are just manifestations of the same thing, but that it's mechanical energy that plays in totality to space travel, where, honestly, there exists no limit to travel.
The Alcubierre drive, a theoretical concept, describes a warp bubble that contracts space in front of a spacecraft and expands space behind it, enabling apparent faster-than-light travel without the object itself exceeding the speed of light locally within the bubble. While Alcubierre's original proposal implied a negative energy density and thus required exotic matter, recent theoretical developments provide a crucial opening for the zero-empty spacefield grid paradigm. These advancements suggest that subluminal, spherically symmetric warp-drive spacetimes might, in principle, be constructed based on positive energy principles. Within the zero-empty spacefield grid paradigm, spacetime manipulation would involve directly altering the state or properties of the grid itself, rather than relying on external, exotic matter. Analog gravity models offer a conceptual blueprint for this approach. These models utilize condensed matter systems, such as superfluids or Bose-Einstein condensates, to demonstrate how effective curved spacetimes and phenomena, analogous to black holes or Hawking radiation, can emerge from the collective behavior of an underlying physical medium. This illustrates how a zero-empty spacefield grid could be manipulated to create acoustic metrics, or similar spacetime distortions, where the metric components evolve dynamically with perturbations. Quantum vacuum engineering further supports this perspective. The quantum vacuum is recognized as a dynamic medium with immense potential energy, far exceeding nuclear energy densities. Vacuum engineering, a concept legitimized by Nobel laureate T.D. Lee, aims to alter the properties of this vacuum to generate novel phenomena. If the zero-empty spacefield grid is this quantum vacuum, then controlled excitation, modulation, or localized energy extraction from its fundamental constituents could produce the desired spacetime contractions and expansions. For example, the field strength of vacuum energy is proposed as an indicator of the bulk or spacetime resistance to localized curvature. Manipulating this stiffness of the grid could induce the necessary curvature, aligning with the idea that gravity itself might arise from the elasticity of spacetime. The core innovation of this approach is to circumvent the need for an external source of negative energy by leveraging the inherent properties of the grid. If the grid itself can be induced to locally push or expand, kind of like an anti-gravitational effect, through its internal dynamics or energy states, then the exotic matter requirement is removed. This could involve creating localized regions where spacetime geometry itself becomes the storage medium for energy, or by understanding gravity as an emergent thermodynamic effect of the grid, where its manipulation inherently leads to the desired space-time modifications. Einstein's famous equation, E equals mc squared, traditionally relates mass and energy, with energy density being the source of space-time curvature. This framework conventionally dictates that negative energy density is required for specific, non-trivial curvatures. However, if space-time is fundamentally the zero-empty spacefield grid, then its curvature and dynamics are primarily functions of its state or configuration, not solely the presence of external mass energy. This implies that the energy required to warp spacetime might be better understood not as a quantity of fuel, but as the energy needed to transition the grid from one quantum or collective state to another, or to induce specific, coherent excitations within it. This shifts the energy calculation from a mass equivalent to a state change equivalent, potentially aligning with the idea that the amount of energy required is no longer thought to be unobtainably large, if the underlying physics is about manipulating the grid's inherent quantum information or entanglement structure. The zero-empty spacefield grid emerges as an underlying dynamic reality that replaces the speculative notions of exotic matter and immense energy. The analysis reveals that the prevailing reliance on these unobserved concepts in the lambda CDM model, especially the profound cosmological constant problem and the elusive nature of dark matter, points to a fundamental incompleteness in our understanding of space-time itself. The zero-empty spacefield grid posits that space is not a void, but a perpetually energetic and structured medium, drawing conceptual strength from modern quantum vacuum theory, quantum foam, emergent gravity, and superfluid vacuum theory. This framework suggests that the phenomena currently attributed to dark energy, such as accelerated expansion, and dark matter, like anomalous gravitational effects, are not caused by mysterious external entities, but are inherent properties or emergent behaviors of this grid. Cosmic acceleration, for instance, can be understood as a consequence of the grid's non-uniformity and differential time rates, as proposed by timescape cosmology, while dark matter effects could arise from the grid's elastic response to ordinary matter at large scales. Blowing away kinetic energy. Kinetic energy is the energy an object possesses due to its motion. It's the energy an object has because it's moving, and it's directly related to the object's mass and speed. The faster an object moves, or the greater its mass, the more kinetic energy it has, according to study.com. Here's a more detailed explanation. Kinetic energy is the energy an object has when it's in motion. It's the energy an object possesses that allows it to do work, like moving another object. The formula for kinetic energy, or KE, is KE equals 1/2 times mv squared, where m is the mass of the object and v is its speed. Relativistic mass energy is based on a solid gravitational field behavior, meaning without gravity, a propulsion force or velocity will not develop kinetic energy because there exists binding field energy that will make it, well, kinetically plausible. Here is another Einsteinian elusigenetic debunking. Introduced by Rodney Kawecki, we will talk about the quanta physics theory framework of 2025. Kinetic energy maintained in relativity asserts a gravitational field elusigenetic flaw, meaning space-time spacefield geometry does not correlate as a standing hypothesis, where the two comparable area metrics do not interact in a twin-field geometric.
Does time actually exist? Some physicists believe time is an illusion. It really doesn't exist at all. But when we research time further, we discover that it is actually just a man-made measurement. Like a ruler, it measures length. In physics, even in relativistic effects, time is not a physical thing. What this means, it's not matter, because matter is made up of elements. Time is not real. It's an illusion. When Einstein developed spatial relativity, he based his original ideas about light with time. His famous statement, "Nothing can travel faster than light." He believed at the time that the speed of light relative to time and space travel, that when approaching light speed in a ship, time slowed down with it. That time stopped at light speed and everything conjectured in the universe, meaning all arpitating in a cycle or rotation that were measured with that specific time measured, all stopped also. That his ship, that tiny vessel 250 miles up in space, stopped the universe. Thus was his claim that the universe is governed by a universal speed limit. Again, nothing can travel faster than light.
Damn, Einstein. What'd you do? Break your bicycle, man?